Guys are doing well. Here's another video for y'all. Today I'll be covering the unit that I'm representing using the Telugu Letter. That check on top of it is a little long. Let me fix that. So this is the Telugu D, and I'm using it instead of Greek because it's overused. Because I feel like Greek is way overused. So let's start off with learning a little bit about the dual numbers, where epsilon squared equals 0. These are already really well known, and they're used for automatic differentiation. So f of a plus b epsilon, and that's any function, is the function of a plus b f prime a epsilon. Or using my notation from the last video, if I can write without erasing everything I do, there we go. Bf d1 a epsilon. Now, this got me thinking, is there a way that we can do the discrete derivative from discrete calculus? I know most people call it the difference, but I find it easier to call it just the discrete derivative. So then I thought, well, let's try something. Let's create a new constant. I'm gonna call it u for now because it isn't permanent. This isn't a permanent constant. And I created this constant with the rule that multiplying xu times yu, where x and y are any real or complex number, equals square roots of x, y times u. And when you go through this process multiple times in a power sequence, you'll eventually find some sort of pattern emerging with the sums of numbers. Let me show you. So let's do a plus bu times a plus bu. So that's a squared, and then u plus u, if I can write, thank you. A squared plus u, and then that would be b. Why is it not letting me write? There we go. B plus 2ab. Or another way we could write this is by factoring out the b, bu 2a plus 1. Next, we will do the cubes plus. Now here's where things get a little interesting. So we have 2a plus 1, and then another a, so u ba 2a plus 1. Actually, I shall factor that out. Not factor it. Yeah, factor it. No, expand it. I'm sorry. I'll expand this out. So that would be 2a squared b plus plus ab, if I can write. Thank you. being a lefty is not helping me out right now. Plus, okay, so that is this times this. Now we want to do this times this, which is just another a squared b. Let me decrease the size of this to like 20. Yeah, that's good enough. So 3a squared b. There we go. Plus ab. And then what's next? So we did that. We did that. We did that. Now what we need to do is this. And this is where the interesting thing comes, because we can do another b, and we'll also be doing a root, and that will end up being, no pun intended, 2a squared plus a, I think. Now with this, I immediately started to notice something may have been up there. Bu2 plus 1, yeah. Something already kind of was looking interesting. I noticed that this was similar to the binomial coefficient. Why am I not allowed to draw here? There we go. 1, 2, 1. And then similar to the coefficient for 3, I saw the 1. Why am I not allowed to draw? Thank you. 1 from here, 3 from here, and then I was looking for the next 3 and 1, but I couldn't really find it. So I kind of hit a roadblock, and then I realized, well, I don't have to make this system commutative. So enter Telugu D, where the Telugu D goes by this rule, if I can draw. Thank you. X d y d equals xd. Or, okay, let me draw. Thank you. My pencil is definitely not liking this. Oh, probably because it got half unscrewed somehow. So, x d y d equals xd. Or in other words, the product of multiple xd's is always going to be the first xd. It's always going to be the first sequence of the product. So I started doing that same pattern again, and I got what I wanted. Let's do a plus b, that, a plus b, that. So we can do a squared again plus b that times, oh, what are we going to do? So we get 2ab like that. And then plus BD times BD is always just the first one. So it's always just the first of the two. So that's just going to be B, which we factor out to 1. So far, so good. Now let's cube it. And again, we'll go through the same pattern. So 2a plus 1 and another a. 2a squared plus a. And then, so we've done that. And we've done that. Now let's do a squared b. So we just add another thing to, we just add another 1 to this, so 3. And then we multiply this b times this b. Let me erase all these stupid lines real quick. There we go. Then we multiply this by this. And since this is just always going to be the first b, remember this is anti-commutative, so we're multiplying this by this. So 2a plus 1 times, well, b, we're multiplying 2ab plus b, all times just b. It's anti-commutative, so we can't just do any order we want. We're doing x squared x and not xx squared. Assuming that's the correct order to do things. This 2a plus 1 would just be add-on to this. 3a plus 1. And I started seeing what I wanted. We have a 1, 3, 3, 3, 3, 1. Now, if we continue this pattern on and on and on, we will eventually find a general power formula for this. A plus b d to the n equals a to the n plus b that a plus 1 to the n minus a to the n. Now, of course, I'm going to show you the proof that this actually does work. I'm not just going to leave you hanging there. So, what am I doing? So, let's do n minus 1, a plus b, that to the n minus 1 equals a to the n minus 1a plus, wait, let me redo this, equals a plus b that n minus 1 times a plus b that. And then we factor everything out. Expand it. What am I saying? A to the n plus b. That times a plus 1 to the n minus a, a plus 1 to the n minus 1 minus a to the n minus 1. And then all that times a plus b that. And remember, and now that we're doing it this way, we can clearly see what order we're going to be multiplying in. So ATN minus 1 times A is just A to the N plus, let's see, BA N minus 1. Now let's start doing this. Actually, let me factor the B out first. There we go. B that, and then AN minus 1. There's that. Plus this entire thing times an A. Plus A plus 1 to the N minus 1. Times A minus A to the N. Right? Yeah, that's correct. And then just plus this entire thing again. So plus A plus 1 to the N minus 1. Then minus A N minus 1. These cancel out. This becomes A plus 1 to the N. And then you get minus A to the N back. So this system works as we thought it would. So now that we've proven this, we can see if we can try and create our own function formula from this. And in fact, we can. We can find a general function rule for A plus B Telugu D. I didn't really draw that well, but who cares? So A to the N, we can just substitute with f of A. Assuming you put this into a Taylor series. I know I'm skipping a bunch of steps, but this formula does work. Plus B Telugu D. And then again, same power n and n. We can just substitute this with f of A plus 1. And then again, same power minus f of A. But of course, this specific combination of functions already has a name given to it and a symbol that you use with it. That is the discrete difference. And I'd say go look it up yourself. It's basically like the derivative, but for differences of 1 instead of infinitesimal differences. That would just be f of A plus B difference of f of A times Telugu D. And there we go. This works for exponentials. This works for tangents, logs, anything. Actually, let's find an inverse formula for this just to see if this formula works. So, x plus y Telugu D equals f of A plus B of A plus 1 minus f of A. Telugu D. Now, obviously, x equals f of a, so we can just find a using this, right? F inverse of x. B, also pretty easy. This f of a, remember, is just x. So now to find b, we got to remember that, okay, so now to find b, we got to remember that this, again, is x. So, let's do y equals f of a plus 1 minus f of a times b. So we just want to divide. So that means b equals y over, then we can just do f of a is f inverse of x. And I'm going to move the 1 over, so 1 plus f inverse x. Minus, then f of a is just x again. So, boom. We've solved this. So sadly, this discrete difference didn't give us the same output for functions and their inverses. But this still works. We just have to say what context we're using a certain function in. Like, are we using e to the x as itself, or are we using it as the inverse of the logarithm, for example? So this system, as a summary, is very interesting. And yes, there are other things that you can do. Like, let me get back to my 314%. There we go. Like we explored, let me write. X Telugu D, Y Telugu D equals X Telugu D. There's tons of other things that we could do with this. We could change that x in the product to a y. We could add a negative to this. I mean, hey, we could even take the symbol out and just do that. Or we could do x Telugu D, y Telugu D equals negative x. There's tons of interesting combinations you could pull out with this. Obviously, there's a bunch more that you could do. You could add like an exponent to this, like do x squared or something like that. But this is the simplest form of this constant. This is the simplest form of this constant, and the version of this constant that works the best is the one that I just talked about in this video. So, thank you for watching, thanks for joining, and I will see you in the next one. Bye!